Okay, for example 4, it says a man starts walking north at a speed of 1.5 meters per second, and a woman starts walking the same point, walking west at a speed of 2 meters per second. At what rate is the distance between the man and the woman increasing 1 minute later? Well, if they're walking north and west, then I can take it on a compass. I'm going to say the point that they spread from is point P. And I know that I have one of them is walking northbound. I know that one of them is walking west. So I can refer to that as my x and as my y value. Now I do know that the northbound one is a man. I know that the westbound one is a woman. And I know that it's asking what is the distance between the man and the woman, or what's the rate of the distance, which means that it's looking for this diagonal that we're going to call Z. And because it's north and west, we know that it creates a right angle triangle, or that 90 degrees. So when we define our variables, we're going to say let x equal the distance of the woman from point P. We're going to let y equal the distance of the man from point P. We're going to let Z represent the distance between the man and woman. And we're going to let T represent the time in seconds. Once again, my rate is in seconds. Now I have to be careful because, like with the last example, I'm going to have that unit change because it says 1 minute later. Now, what do I know? Well, I know that the speed that the woman is walking is 2 meters per second. I know the speed that the man is walking is 1.5 meters per second. And I know that I'm trying to find the change in the distance between them, or that dx or dz over dt. But the question also told me that t is equal to 1 minute, which in this case is 60 seconds. Well, if my t value is 60 seconds, then that means that my x is going to be my speed times my time, which is going to give me 1.5 times 60, which is, sorry, not 1.5 for x, 2 times 60, which is 120 meters. My y is going to be that 1.5 times time, which is 90 meters. And my z, because I know my x and my y, is going to be the square root of 120 squared plus 90 squared, because it creates a right angle triangle and the z is the hypotenuse, which is going to give me 150 meters. So because it told me my speeds and my time, I can use that to figure out what distance they currently are. Now, this is all based on the Pythagorean theorem again. So it's based on the idea that x squared plus y squared is equal to z squared, which is how we'd figure out what our z is at any given point. I'm going to differentiate this and get 2x dx over dt plus 2y dy over dt is equal to 2z dz over dt. And I'm going to divide all of these by 2 to cancel that out. And I know my dx over dt, dy over dt, my x, my y, and my z. So I'm just going to substitute all those values back in. So what do I have? I have x is 120, dx over dt is 2, plus y is 90, dy over dt is 1.5, is equal to z is 150, times dz over dt, which is what I'm actually trying to solve. So dz over dt is going to be the same as 120 times 2 plus 90 times 1.5, all divided by 150. This is going to give me 375 over 150. And when I simplify that, I'm going to get 5 over 2 meters per second. Therefore, the distance between the man and woman is increasing at a rate of 5 over 2 meters per second when they are 1 minute from point P. Example 5. A point moves along a hyperbola, x squared minus 4y squared is equal to 36, in such a way that the abscissa increases at a constant rate of 20 units per second. How fast is the ordinate changing at the point of 10 and 4? Well, first off, we have this, that's not what I meant to do. We have this hyperbola where it's going to look something like this. So the first thing is, I should know what a hyperbola looks like. Second thing is the abscissa. That's just a fancy way of saying the x coordinate. And the ordinate is a fancy way of saying the y coordinate. Now this is important because in this case, given the information that we were told, we should know that the abscissa is increasing, so dx over dt is equal to 20 units per second. And we're trying to find how much the ordinate is changing, which means that we're looking for dy over dt. And this is at the point of 10 and 4, which obviously is my x and my y. Well, we have our equation because it was actually given to us. X squared minus 4y squared is equal to 36. And when we differentiate in terms of time, we get 2x dx over dt minus 8y dy over dt is equal to 0. Now, we know dx over dt, we know x, we know y, which means that we're going to sub those values in and get 2 times 10 times 20 minus 8 times 4 times dy over dt is equal to 0. And once again, we're just trying to isolate that dy over dt. Well, when I multiply out the first part, I get 400. 8 times 4 is 32. And I'm multiplying that by dy over dt. This means when I move the 32 dy over dt over, or move the 400 over, I get 32 dy over dt is equal to 400, which means that dy over dt is equal to 400 over 32, and I can divide the top and the bottom by 16 to get 25 over 2 units. Therefore, the ordinate is changing at a rate of 25 over 2 units per second at the point 10 and 4.